Inverse functions are the bomb. If you're watching this video, you better be doing math methods, or else why the hell are you watching this video? VCE math methods, right? Alright, Mitchie, inverse functions. They are popular. Teachers love these. They love it. I don't know why, but they have this love affair with inverse functions. And inverse functions are like the simplest thing ever. Simplest thing ever. Simplest thing ever. Okay, they are simple because there are 4 rules. If you remember all 4 of these, all 4, how many? 4. That's right, 4. If you remember all 4 of these rules, they become so simple. It's like, wow, that was so simple. So, inverse functions. First of all, before we go on to the 4 rules, let's just talk about what they are so you can identify them. Now, if you can't identify them, then I have news for you. You shouldn't probably be watching, you're probably not watching this video. And there are lots of cool videos of little cute kittens on YouTube. Watch them instead. Alright, so it looks like this. Now, this is not inverse functions. This is differential. So it's not a little dash, it's the -1. Yay! Okay, so inverse functions, let's talk about the rules, because we all love rules. How many rules? You've forgotten 4. Rule number 1. Rule number 1. Okay, rule number 1. It has to be a what? That's right, one-to-one function. Has to be a one-to-one function. Okay, what's a one-to-one function? That means they have to pass through both the vertical line test and the horizontal line test. So is a parabola a one-to-one? No, because it fails. Ba-bam. Boom. Okay, so that's no good. So what can you do to a parabola in order for it to be a one-to-one? You have to chop it. Yes, you have to chop it. And usually you can chop it right in the middle, or you can chop it on one side as long as it's now a one-to-one function. So what are some one-to-one functions naturally? Well, exponentials is a one-to-one, logarithm, good old square root graph, we love the square root graph, hyperbola, is truncus? No, because you got to chop in the middle, exactly. So it has to be a one-to-one, and some of the questions, some of the dumbass questions would ask you, oh, can this have an inverse function? And it's usually a 1-mark question, and you just have to say yes because it's a one-to-one, no because it's not. Okay. Number 2. Okay, what's number 2? Number 2 is that x is now y and y is now x. So how does that affect me, says you? Well, first of all, most questions, talking makes me thirsty, math makes me thirsty. Okay, so this is how it works. Whenever you have to find the equation of an inverse function, okay, this is what you got to do, right? You got to swap the x with a y. You probably know this. But also, what most people don't realize is it's literally, now the x is up here, the y is down here. Now, I don't want to confuse you with this. I'm like, whoa, you're totally spinning out my paradigm here. But basically, it's almost like the y-axis is swapped with the x-axis. I'll rub this off just in case, people are getting tripped out still. So x swaps with a y. For example, I'll give you an example. Y equals x plus 4. Okay, so x now equals y plus 4, and you always got to make y the subject because y is the boss. Y equals x minus 4, because you take the 4 on the other side, and boom, there is the inverse function. The rule of the inverse function. It's fairly simple. Alright. Rule number 3. Number 3. Okay, this is sort of related to this. X is the domain, y is the range. So the range swaps with the domain. The range swaps with the domain. Simple enough. Excuse me. Domain, range, domain. X, y, y, x. So that means the old domain is now the new range. The new range is the old domain, the old range is the new domain, you get it. You get the point, right? Domain and range swaps. So a lot of the questions in exams, they're going to ask you, what is the range of the new inverse function? Well, that's the same as the old, what did I say? Old domain, right? That's the old domain, new range, old domain. So you just find the old domain instead of finding the new range, because domain is always easier to find than the range. If you didn't get that, rewind, watch it again. It makes sense. Trust me. I'm a pro. Alright, last rule. This is more of a graphical rule. And most of you guys will probably know this, but basically everything is now reflected along the y equals x axis. Y equals x because that's the diagonal, 45-degree diagonal line, right? Everything is reflected. So to make this easier, let's draw, okay, if something looks like a butterfly, it's like those things you did in prep, you know, you painted like half of the paper and then you fold it in half and it's like, oh, it's a cute butterfly. So on the other side, it just reflects like that. That's it, okay? Don't ask me for the function of that particular graph. I don't know. Okay, now, here's something interesting about this graph. This is very important. This is one of the more advanced pieces of the inverse function, okay? So, here's what happens. Whenever you have a graph like this, and sometimes, especially in later years, 2012, 2011, what examiners have started doing is that they've started asking you to find these points. Yes, that's the butterfly's butt. And these points, okay? Points of intersection between the f of x and the f of -1 of x, which is the inverse. Okay? They've started to ask you about these things. Now, it would be very, very easy, because I know you're smart, you just go, oh, intersection, you equate them, right? So you equate something like, let's say, the original graph was e to the x, you equate it to log e of x, because they're the inverse of each other. You knew that. But that's very hard to solve, okay? And there's a different way, there's another way. The other way is, don't just think that there's only two graphs here. There's three. The other graph is the y equals x. Okay, so that also equals to x. That also equals to x, so that's the other function. Because whenever they intersect, it always has to lie on the axis of y equals x. Do you get that? Alright, it's a bit of a whoa, like whoa. When I first learned this, I'm like, whoa, that's so cool. I didn't say that. But it equals x. So that means you can possibly have this equation, which may be a little easier for you to solve in that particular case, or you can have log ex equals x. Okay, you don't have to equate both the function and the inverse function together. You can equate it to x as well to find those intersections. So just keep that in mind. Alright, so they conclude the 4 rules of inverse functions. If you remember these 4 rules, you'll be awesome in math methods. If you watch this far into the video, you'll be awesome in math methods. Man, is there really anything more to... Or I'll give you an example. Fine, I'll give you an example. God, stop bugging me. It's like Saturday. I'm doing this on a Saturday. You think this is fun? You think I'm having fun? Damn right I'm having fun. Alright, so let's do an example. F of x equals, wanna have some fun? -2 e x minus 5 plus 7. Now, most of you guys out there, Mitchie, that's you included, you'll be like, ooh, that's a sexy equation. I know, I made it up myself. Alright, so let's find the inverse of this. First of all, is that a 1-to-1? Yes, because it's an exponential. You knew that. Second of all, okay, so how do we go about getting f -1 of x, the inverse? Well, we make good old, let's pretend that's y for a second. Now, by the way, is y the same as f of x? Yes, they are, but they're not sort of changeable. You can't just change one for the other for some reason. No maths teacher ever told me why, so if you know the reason, let me know. But I think the reason is lots of smart mathematicians from all around the world came up with 2 different solutions and they didn't agree on it because it didn't make they didn't want to convert. They didn't want to convert their system into the other people's. So we just have 2 different systems of writing this. It's dumb, I know, but that's what happens. Okay, so let's say it's y. So now you change y with x. X equals -2 y x minus 5 plus 7. And the next step, oh my god, did you see the mistake? Oh my god, did you see that? I cannot believe I did that. I told you, it's Saturday. E didn't suddenly become y. Okay, so it looks like that. Now, next thing, swap everything, transpose, you know how to do this, make sure you do it in the right order. So 7 goes over first, yes. -2 goes over as divide, yes. E goes over as log e, of course you knew that, that's the tricky step. Not tricky. and negative 5 goes over to plus 5. So if you want to do it all in one go, it looks something like this. X minus 7 all over negative 2 log e plus 5. Sexy, I know. Alright, so it looks like that. That's a 2, but no, that's not a 2, that's an e. Okay, so it looks like that. Now, the most important thing here is you got the equation. Can you simplify that? Nah, it looks pretty cool as it is. So I would leave it like that. To find the domain range, well, that's when you just got to know your graphs, right? You just got to know your graphs, and to find the intersections, blah, 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 you know how to do that, okay? So the most important thing here is know how to transpose properly. If you know how to transpose properly, then you're awesome. Go out, do some of this stuff. Checkpoints. Did I mention checkpoints? Okay. There's been so many students I've tutored in the past and helped in the past that don't start checkpoints early enough, and they wait till it's too late, and suddenly there's just all this work. By the way, term 1, term 2, yeah, it's kind of cruisy. Term 3, your ass is on the line, and that is just too late to start doing this, because then you have so much fire up your butt that you don't even have time to do the things that aren't so-called necessary, okay? So start doing this now, today, right now. I don't care if it's 12 o'clock at night that you're watching this, do it now. Wait, stay up, okay? I stay up all the time till 3 a.m. doing work. You better too. Alright, so that's inverse functions. Hope you enjoyed it. I'll talk to you very soon.